Number 8. The resistance of a sample of a medium-strength bronze alloy trolley wire is measured in order to determine its resistivity. The cross-section is circular and the diameter is 0.460 inch. Number 30. The resistance of an 38-inch length is found to be 2.39 2 times 10 raised to negative 4 ohm at a temperature of 20 degrees Celsius. Determine A. Resistance per foot. B. Resistivity in ohm inches and in ohm centimeter. C. Conductivity as percent of international copper standard of 1.724 micro-ohm centimeter. Okay, so let's deal with our resistance per foot first. Resistance per foot. We all know that the resistance is already given. The resistance of a 39-inch length is found to be. So that is already, this is our resistance. Okay, so let's solve for it. So our R per foot is equal to 2.392 times 10 raised to negative 4 ohms per foot all over our length, which is 38 inch. We need to convert inch to feet. In every 12 inches, 1 foot. So let's cancel out common unit. So inch. So the remaining unit is ohms per foot. Okay. So what is the value of your resistance per foot? That is equal to 2.392 times 10 raised to negative 4 all over your 38 inches converted to feet. That is equal to 75. That is equal to 75.53684211 times 10 raised to negative 6 micro ohm per foot. Okay. Now that we have our resistance per foot, the second unknown is resistivity in ohm inches. So I'm going to save the value of my resistance. The resistance is here. That is the resistance per foot. I'm going to save this to my memory A. That is 2.392 times 10 raised to negative 4. So that is the value of my resistance. I'm going to store it at A. Okay. Let's determine the value of our resistivity. Okay, let's move to B. So for B, if we recall the formula for our resistance is equal to the resistivity length all over the cross-sectional area. Let's check the availability of our data. Do we have the value for our resistance? Yes. Do we have a value for our resistivity? That is our unknown. How about for our length? Yes, that is 38 inches. How about for our cross-sectional area? Yes, it is given with circular. The cross-section is circular and a diameter of 0.460 inch. That means our cross-sectional area, if we determine our cross-sectional area, that is equal to, since it is circular, it is in a cylindrical shape, that is 1/4 pi square of your diameter, which is the diameter is given. Okay, I think we can solve for our resistivity. Transposing in terms of resistivity, therefore, our resistivity is equal to the resistance times the cross-sectional area all over the length. Okay, so we're going to use this formula. Okay, doing so, finally, our resistance, our resistivity is equal to our resistance, which is same in alpha A, that is alpha A, and our length, I mean cross-sectional area, which is this one. So this is 1 over 4 pi the square of diameter, which is 0.460 inch. And how about for our length? Our length is in inch also, so there's nothing to worry. So this is square all over the length, which is 38 inches. Okay, so let's cancel out common unit. What is the unit of our resistance here? This is ohms. Okay, so what will happen? So we cancel out one of our inch. So 1 of our inch. Okay, so finally, our resistivity is equal to 0.460 squared all over 38 inches. So our resistivity in inches, that is 1.046123898 times 10 raised to negative 6, so that is micro-ohms per inch. We already have our value for inch. How about for centimeter? We simply convert inches to centimeter. Okay, so we store this to our memory B. Okay, so once we do, our memory B, the unit is in micro ohms inch. We convert it, so in every inches there are 2.54 centimeter. So we cancel out the inches and the remaining unit is in centimeter. So finally, our resistivity, so this is in inches and this is our resistivity is in centimeter. So what is the value? So alpha B times 2.54. Our answer here is in centimeter, that is 2.657154,701 times 10 raised to negative 6, so that is micro ohm centimeter. Okay, so we already have our value for our resistance per foot, resistivity in ohm inches, and ohm centimeter. So what is our next? So we solve for our conductivity as percent of ICS. But before doing that, remember our conductivity, our conductivity is equal to the reciprocal of your resistivity. Okay, so let's see. So the ICS standard, the ICS International Copper Standard, they use 1.72 for micro-ohm centimeter. So we're going to use the resistivity in centimeter. So if we try to check the value, the formula for our conductivity, that is the reciprocal of your resistivity. We save our resistivity first in centimeter. We store it on our C. Okay, so I already stored it. So now we can determine right away our conductivity. Like in our previous lecture, what do we do here? So we use the reciprocal, or the inverse of a number, in your calculator. So we input C, then we click our x raised to negative 1, or that is the reciprocal. So this is now your conductivity in centimeter. Okay, let's do that. So alpha C, the reciprocal of alpha C, that is equal to 376,342.4085 mo. Okay, so that is the unit for our conductivity, which is that is equal to mo per, since it will be inverse, so mo per centimeter. But wait, the question is conductivity as percent of that international copper standard, which is equal to 1.724 micro-ohm centimeter. Okay, this is the resistivity of standard ICS. If we have the resistivity in terms of conductivity as percent, we need to get the conductivity, or the inverse of the international copper standard, 1.724 micro-ohm centimeter. Doing that, the conductivity of our international copper standard, which is 1.724 micro-ohm centimeter, we get the inverse of that. So once we do, we have the value of our inverse of our resistivity of ICS 1.724 micro-ohm centimeter, that is equal to 580,046.4037. Okay, we have the unit is in mo per centimeter. Okay, so we store it to value, we store it in our memory E. Memory E. How about here? We store it in our memory D. Okay, so we stored it on our D. So now we are tasked to determine the conductivity as percent of international standard. Therefore, our conductivity as per international standard, that is equal to our percent equal to our resistivity, our conductivity of our materials, that is in alpha D, and the conductivity of our ICS, which is saved in alpha E, and times to 100%. So here we can determine the percentage of our bronze trolley wire, that is equal to alpha D all over the alpha E times the 100%, is equal to 5.8 is not safe, so 1.724 times 10 raised to negative 6 inverse store at alpha E. Okay, so alpha T over alpha E times 100% is equal to 0, 0.6488143122, or equal to, in percent, that is 64.88%. Okay, so that is the percent conductivity as per to ICS standard.